Grandma Secret online. If you know you have not subscribed, please you can help us to subscribe so that anytime we post video that you can be able to watch the video. We do post this type of video Friday. Please you can help us to subscribe to encourage us. Thank you. Topic is federation. Objective: at the end of this video, you should be able to know the relationship between two variables using direct federation. Use the concept of inverse federation to solve problems involving inverse proportionality. Use the concept of joint federation to solve problems involving more than two variables. Lastly, use the concept of partial federation in solving problems. We have introduction. A. The variables could be two or more. It could be direct, inverse, joint, or partial. If variable A increase as variable B increase, then A is directly proportional to B. If there is increasement in A and B also increase, A is directly proportional to B. That is one of the language. A is directly proportional to B. And what does this mean? Is that A is directly proportional to B. This is what it means. The second one, if variable A increase and B decrease, then A is inversely proportional to B. This is what it means. A inversely proportional to B. Right? In C, down, in joint federation, the variables can be more than two. For instance, if A is jointly proportional to B and C, then it will now be A proportional to joint to B and C. Right? These are the statements that you will come across when you are solving any question in federation. Let's see the first one, which is A. A is directly proportional to B, which is A directly proportional to B. It will come this way for this statement. But the one thing that this alpha sign, what are you going to do with it? You will introduce it with equal sign and a constant. Now, A will be equal constant B times B, right? This will now be equal to this. When you introduce a constant K into it, it will become this. Now we come to B. If variable A, right, increase and B decrease, then A is inversely proportional to B, which is inverse of B. Then this will now be equal to A. Let's remove this sign, introduce equality sign and K, which is multiplied by 1 over B. So then A will now be equal to K over B, where K is a constant, right? Let's come to the last one, C. C said if joint federation, the variables can be more than two. For instance, if A, if A is jointly proportional to B and C. Now, this is it here. So, A proportional to B and C. Then A will be equal K, B, C, where K is a constant, right? So, these three equations that I derive from here now, we can start using it to solve variation quotient. We have examples here that we continue together to solve this example. You can understand it more better. Now, let's see the example 1. Example 1 says, if A is directly proportional to B, this is the directly proportional to B, right? From we have the first one, which is from our figure 1. A is directly proportional to B. The first one, A, is directly proportional to B. It will come this way. Now, let's remove this our alpha sign and introduce equal and a constant. Now, it will now be A equal KB, where K is a constant. K is a constant. Then you come here, we see that A equal to the value of A given equal to 36 when B equal to 9. Now let's substitute this value into this our equation. This is our equation here. We substitute the value given into it for us to get our K as a constant value. A equal to K. B, what is our A? A is 36. Will be equal to K multiplying by B, which is 9, right? So here will now be K will be equal, when you divide both sides by 9, we have 36 divided by 9, which is will be equal to 4, right? So now let's substitute this value, this 4, into this equation back. Then we have our A will be equal 4B. This is now the equation that we'll be using to solve the other quotient, which is Roman figure 2 and Roman figure 3, right? So from there now, the second one said this is the first relationship between A and B. That is the first answer. The second one, A, we are looking for the value of A when B equal to 3. Now we substitute this value now into this equation. From here now we have our A, which is A here will be equal to 4B as our equation. We are looking for the value of A. We are given 3, B as 3, which is 4 multiplied by 3, which is 4 times 3 will become 12. So the value of A now is 12 when B equal to 3. That is the second one. The last one there, we are looking for Roman figure 3. Now we are using the formula, which is A equal to 4B. So now we are looking for B when to 32. Right. So let's substitute the value here. We have our 32 here be equal to 4b. So when we divide both sides by 4, right, we have our b be equal to 32 over 4. 2 goes here, 2 goes here, right? And 2 can still go in 6, which is will be equal to 8. Then when a equal to 32, b equal to 8. This is the answer. Let's move to the second one. Now the second example say if r is directly proportional to the square root of x, when r equal 12, x equal 36, find number 1, r when s equal to 49, and 2, x when r equal 6. Now let's start from the first one. You see, if r is directly proportional to the square root of x, right? Here, when r equal 12, x equal 36, right? This is the value given, 36. To remove this proportional sign, which is r be equal to k square root of x, right? So from here now we have our r as 12. Let's substitute the value now. We have our r as 12 be equal to k square root of 36, and the square root of 36 will be equal to 6, right? 6 multiplied by k, so 12 will be equal to k multiplied by 6. Now let's divide both sides by 6 for us to have the value of k, right? We have our k will be equal to 12 divided by 6, which is equal to, right? So our k now will be equal to 2. Let's substitute this value into this our equation. This equation, we substitute the value into this equation, right? So from here now we have our r will be equal to 2 square root of x, right? This is the relationship between r and x, but that the question is not, we are not looking for the quotient here. We ask us to calculate that. So the first one, Roman figure 1, now we are looking for r when x equal to 49. We are looking for r when x equal 49, right? So from to the value here, we have our r we don't know, that's what we are looking for, be equal to 2 square root of 49, right? And we know that square root of 49 is 7, and 2 times 7 is 14, right? Our r equal to 14 when x equal to 49. And the second one, x when r equals 6, x when r equals 6. Let's substitute the equation, the data given in equation. This is our equation that we'll be using now, right? So which is r equal to square root of x. R is given, which is 6. We have to square root of x. Alright. So from there, let divide both sides by 2. We have square root of x will be equal 6 over 2, which is 3. Right? We have square root of x now will be equal to 3. Now, how can we do away with this square root? Is by square both sides. We square the both sides. So from here, what we do here, we do the same thing on the right hand side. What you do in the left hand side, do the same thing in the right hand side. So we have our square root of x raised to power 2 equal 3 raised to power 2. Right. Now, square root of this square root is the same thing as x raised to power half multiplying 2, which is equal to 3 times 3. Alright, here we cancel this. So we have our x now as equal 3 times 3 to give you 9. So this will be the answer when r equals 6, x equal to 9. So this is the answer for that. We'll move to the third question, example 3. If A is inversely proportional to B, here, let's see the first one. If A is inversely proportional to B, right? When A equal to B equal 3. Now let's substitute that. But it's before that, we know that we need to remove proportionality sign and introduce equal and a constant. We have our A will be equal to K times 1 over B, which is the same thing as K over B. Right? Now let's substitute this value for us to have our constant. We have our A as 2. Our K, we don't know. That's what we are looking for now. B equal to 3. Cross multiply. If we cross multiply, our K will now be 3 times 2, which is equal 6. Right? Let's substitute this value back into this relationship, which is this relation will be equal 6 over B. Right? This now be the relationship between A and B. And the second one says that A, we are looking for the value of A when B equal to 2. A when B equal 2. Right, this is from our figure 2. We are looking for A when B equal 2. Right, by using this formula, we have our A, that is what we are looking for. A equal 6 over B. Our A, we don't know, 6 over 2, which is equal 3. Therefore, our A will be equal 3. This is the value of A when B equal 2. Now, you have the third one right now. The third one, which is Roman figure 3. Right? And we are looking for what? A. We are looking for B when A equal 12. A equal 12, what will be the value of B? Now remember the equation, which is A equal 6 over B, right? A has 12, B equal 6 over B. Now when you cross multiply, it will be 12B will equal 6. Let's divide both sides by 12. We have 12 here, we have 12 here. 12, we cancel 12 here, right? So from here now we have 6 can go here 1, 6 can go here 2, which is 1 over 2. So our B equal to 1 over 2 when A equal to 12 is the answer. Let's see the last one now. This is the fourth example now. If A is directly proportional to B and A is inversely proportional to C, when A equal to B equal 3 and C equal 6, find the relationship, which is the equation connecting A, B, and C, and C when A equal to B equal to 10 and B equal to 2. B when A equal 3 and C equal 2, and A when B equal 5 and C equal 3. This is the questions now. But you come to this very place. The first statement say that if A, let's have our Roman figure 1, if A is directly proportional to B, let's come to our proportionality sign. We have A directly proportional to B. This is the first statement from the first sentence. The second sentence now say A is inversely proportional to C. A again is inversely proportional to C, right? This is how is it going to come. This is the first statement. This is the second statement, right? So from here, what can we do now? Let's marry the two statements together. We see that A proportional, you see that our A is proportional to B over C, right? Now let's introduce our equality sign and constant, which is A will be equal to K B over C, right? But you come here, you see that when A equal to, B equal 3 and C equal 6, right? Now we substitute this value into this equation. This is our very equation. We substitute the value into it, which is here we have our A, which is equal to, right, our equality sign, okay, our B, which is B is 3 times 3 over C, C is 6, right? So from here now, 3 goes here, 2, 3 goes here, 1, right? So we have 2 equal K over 2. When you cross multiply, K now be equal to 2 times 2, right? So our k will be equals, constant will be equal to 4. This is the constant value. Now let's substitute this constant value into the equation. So we have our a will be equal 4b over c. This is the equation that you'll be using to solve questions that are Roman figure 2, 3, and 4. Right. Now we go to Roman figure 2. Now this equation is the equation that connects A, B, and C. This very equation that we have now is the one that connects the A, B, and C. Roman figure 2 now. Roman figure 2, we are looking for C when A equal to 10 and B equal to 2. A equal to 10, B equal to, and C, that is what we are looking for. All right. So this is the formula we are using now. A equal 4b over c. Right. What is the value of A? Is 10. We have 10. B equal 4 multiplied by B. B is 2 over c. It will be equal, imply that 10 will be equal to 4 times 2. That's 8 over c. Right? When we multiply, cross multiply, 10c will equal to 8. Divide both sides by 10. Right? 10 will cancel this 10. So from here now we have 2 goes here, 4. 2 goes here, 5. Will equal 4 over 5. Look at the third one, which is B when A equal 3 and C equal 2. When A equal 3, we are looking for B. A equal K, that's 4 B over C, right? So A is 3, we have our 3 here. C 4B over 2. 2 goes here 1, 2 goes here 2. So then we have our B now will equal to 3 over 2. B is equal to 3 over 2, or 1 over 2. Figure 4. So we are looking for A when B equal 5, C equal 8. B equal 5, C equal 8. We are looking for A, which is A equal 4B over C, right? Or A equal, that's what we are looking for. 4 times 5 over 8. So it should be equal 20, which is 2. 4 goes here, 2, right? 4 goes here, 1. So it will be 5 over 2 or 2 1 over 2. This will be the answer. Thank you. Please, if you know you have not subscribed, please hit help us to subscribe, please. Thank you.